Hello, everyone, and welcome to our Apply Analytics to Improve Operations and Management webinar. I'm Lauren Scheibe. Before I introduce our speaker, I'd like to welcome and encourage you to engage with our expert today by using the Q&A box located in the right corner of your GoToWebinar interface. We will try to answer as many questions as possible during the last 15 to 20 minutes. Please note that all phone lines will be muted during this webinar. After the webinar, we will send an email with a link to watch the webinar on demand. I'd like to introduce our speaker today, Brett Singley, Sales Engineer at Innovyze. Brett worked at an international consulting firm as the National Distribution System Modeling Lead for the United States, and he has worked on dozens of master planning and modeling projects over the years, all over the country and internationally. Since joining Innovyze in 2015, he has worked hard to help other water experts understand the most effective tools to approach difficult problems in his technical sales role. He has also been a dedicated product manager. Brett strives to bridge the gap between real-world problems and technology, developing innovative solutions to solve our customers' needs. Brett is passionate about improving workflow processes and using computers to automate the boring parts of our job that don't require critical thinking. Brett, I'll hand it off to you now.
Excellent, thank you. So I'm just to go over the agenda, what we're going to cover today. We're going to talk about, just in general, an overview of what operational insights are for utilities, give you a few examples there. We'll do a kind of a deeper dive into some of the software to show you what it looks like on Info 360. Then a large portion, we'll be talking about specific problems that have been solved with this solution and kind of an action list, a kind of a plan so that you can be on your way to be able to use all the data that you've been collecting for a long time and start to take action on it. Starting with configuring the data, identifying those key performance indicators that will apply to the things you're trying to accomplish, doing the actual analysis to gain the operational insights, and then taking those insights and moving to actions. We'll also quickly touch at the very end about how important this is to innovate with your internal staff and when it might help to bring in some external expertise in some of these cases. And we'll obviously finalize, as Lauren's mentioning, with a Q&A session, so definitely please interact with us and ask us questions throughout. We'll also be asking you a few questions, which is actually where we'll go next. I want to kind of just find out where people are to start. So this poll question is, how would you describe your data access situation? A, I have amazing access and can create my own dashboards and KPIs. B, I have access to the live and historical data, but it's cumbersome. C, I have to ask someone else for live and historical data. Or D, I don't even know who to ask, and I have no need for the data. We'll let this go for a little while. And this is, I just like to get kind of a read of the room before we jump into a lot of this, just to find out where people are. Our next question is another similar one. We'll give this one, and it looks like we got some pretty good responses. We'll go ahead and jump to the second one, which is, has your organization considered analytics and data visualization tools? So we just kind of want to know if you're already doing any of this, if you're just starting to investigate, or if you're somewhere in between, you're looking for a solution, and that's why you're here. So just wanting to know basically how much background you have in this, or if this is new stuff for you. Might affect the way I present some of the information. So it's looking like we've got a lot of people, just so people are aware, we've got a lot of people that are just now starting to investigate. Nearly 50% of the people responding right now are in that boat. So we'll make sure that we show you some stuff that should be interesting and show you why you need to start looking into it a little bit more seriously. I'll give it just a couple more seconds. And excellent. All right, so I asked those questions. Yeah, that first question is very kind of pointed at what I've seen out when I've gone out to talk to people about this stuff. In general, organizations are often very segmented and siloed. You have operators that have no interaction with engineers, or even within an engineering department, the planners versus the designers and things like that. And management has oversight over all of them, but even management gets siloed within the management group at times. So we're just highlighting the fact that a lot of this data that we'll be discussing today might reside in one of these silos, might be used mostly by one of these groups, might be managed by an IT group. But one of the biggest things that we have to try to accomplish in kind of democratizing some of this data is to be able to push it out of these silos and show people what the value is of having this data available to everybody. So when we talk about all this data, here's some of the sources of that data. The one that's probably the most popular that people think of when you think of a ton of data is SCADA data coming in on water and sewer systems. We've got flows, pressures, levels in tanks and wet wells, whether pumps are on or off, valves are open or closed. Those kinds of things are constantly being fed into control rooms all over the country. And a lot of times that data is just sitting there. We look at all these other sources as well, different new IoT devices that are getting so much cheaper and easier to put out and distribute throughout your system. Water quality data results from hydraulic models on places where you might not have actual sensor data out in the system that can help you estimate what's going on in between sensors. All these different things, and the data sets are coming, they're being collected, they're sitting a lot of times very dormant, and it's hard to derive insight from that data if you don't have access to it, or if it's really hard to get access to it. So what we've done is we've created a product to help democratize that data, to help get it in front of people. Info360 is here to kind of help you with real-time analytics, help you with some workflow automation. There's just a lot of reporting and a lot of things being done in Excel and different tools that can easily be done automatically when you put the data with the right tool. Sensor health is a new one that we'll talk about. If you've seen some of these in the past, that'll be a new one for you. Alert management, being able to be alerted on something that you're interested in and not just what specific people in operations cared about when original SCADA was being put in. It's a big deal, the ability to create those on the fly based on specific projects or for different initiatives that start up. And then the last one on here is kind of system forecasting. We can learn a lot about what's coming by looking behind us and analyzing some of that data. We'll talk about that a little bit later in a slide. Ultimately, though, having a tool that makes that stuff available doesn't matter if you don't have a plan and you don't have a problem that you're trying to solve. We don't create these products just to make them available so that we can show you a pretty graph. We want to try to solve the problems that you guys deal with, and that's something that we have really kind of prided ourselves on in that discussion. Mentioned it in my bio. I've been in the industry for a long time. I came to this company in particular because I saw the progress that they had made in helping my job be quite a bit easier as I was doing modeling and master planning and helping cities kind of progress towards a more accurate depiction of their, a computer model of what was really going on out in the system. So we've been around the block. We know the pains that you're going through. We'd love to hear more, so please reach out to us at any time to fill us in with more info that you have that we can help solve your problems. But I just wanted to emphasize here that the tool in itself doesn't do anything for us. There has to be problems that we're solving, and so that's what we're really emphasizing here and kind of training people on is let's figure out what those problems are and then work towards them. This slide is just really quick for some that have been following this product for a while. Some new things are in the latest version that just dropped earlier this year. Some things that really stand out are some of the data integrity things with the ability to see how often you're getting data from out in the field. Also, we've changed around some of the way that we do alerts that we'll emphasize and created some new tools for you. Ultimately, though, you'll notice as I give kind of a demo of the software that one of the biggest things is just being able to bring in a bunch of data from a lot of different areas, put them into dashboards, be able to create quick reports with the data that you need, and then be able to access them from all over the place, anywhere you got a computer, tablet. With that, we'll dive into the actual software overview. Pull this up here. So start off just with the main website here. So this is what the landing page is. Each individual, so I'm just in a Chrome browser here, each individual has their own login, so they can have the whole setup aimed at what they do every day and what they're interested in seeing from the data, the insights they're trying to gain. When you get to the landing page here, it will show you kind of the recently opened things that you've worked on most recently and have the tools available to you so that you can work with them. I'll go to this one. It's the workspace that was made based on burst information, but I want to emphasize up top here we have the mapping functions. So you can click on a sensor. This is a flow sensor, and you can see there's gauge charts, historical charts, and just being able to export the data at any given time. You can just click on something and spit it out to Excel if you want to do it that way. Found people don't use that as much when they can see it so beautifully here. So when we click on that historical chart, you'll see all these other charts that I already have in this workspace. We call them dashlets and charts. But when I click on that historical chart, it will pop down that data and have it available for us to see it. This is some flows in a system that you see. This is over multiple days. This is hourly data. You see there's kind of a peak up there on the right. There's a little high point. So I'll show off that, some of that alerting in this other workspace. You can look at things like that are peaking over specific numbers or dropping below a certain number. In this one here, it's showing some tables down below that shows when alerts have happened. And once a certain criteria, the one here we have that I like to use, that is pressure that goes above or below a certain range. And if you had those things alerting, you can also search for them on the historical graph, just like this, and it shows you what triggered that. And this one, it happens all the time. But if you were on one that there was one event where it spiked one time and you didn't remember when it was, you could look at all your historical data and do that same search and find out where it happened, and then be able to kind of zoom in and find out what was going on there. Again, we'll talk about some of the new functionality in how to set up some of these alerts later, but this is what it would look like after you've created the alerts and how you can prioritize those things. Just in case there's any differences. I'll go over to a system-wide just to show you what some different variety of dashlets that you can put in here. You'll see one here to the right that's just got a web dashlet that goes straight to a website that's just pulling weather, because they felt that was useful information while they're looking at their system-wide. We've got tank levels all mapped there. We've got some of these bar charts are showing produced water versus purchased water. Down here, we've got our mass balance. So that's showing a simple in minus out minus change in storage, and that one on the top left. But what that does for you, and you don't have to know how to do the math yourself, you just point in the arrows saying this is the flow in and flow out. It creates this usage pattern. And this is the same thing. I'll show you later a spreadsheet that I used to use to create this. But this is on all the historical data. And when you look at this one, it kind of stands out that the peak in the middle there is quite a bit different than the day before, and even pretty different from the day after. So this is an example where we were with a client with the Yorba Linda Water District, and I said, "Woo, you're going to calibrate to that day. Let's make sure. Let's check it from comparing it to the data from a week before to see if this was an anomaly and maybe there's bad SCADA data." When we did it, we realized how powerful this tool can actually be. And you can see that without doing anything but saying, hey, plot the data from last week on top of it, we can see that it's really similar week to week in that hot part of the year, and that they have a really drastically different usage patterns day to day. When you look at the winter, you can still see some patterns that definitely still are following trends, maybe not quite as close as the stuff that happens in the summer when outdoor use is such a big impact. I highlight that here just to show different ways that you can show that same data. So on the left, we've got January usage, so it's a lot flatter of peaks. You get peaks when people are using the water versus the summer, where our peak is clearly kind of the outdoor use is causing a ton of water being used. The scales there are pretty drastically different too. Not sure how small it is on your screen, but it's 3 times, actually more than 3 times on that peak on the difference there. So fun ways to look at that data that really just was too hard to do in spreadsheets, and even when you use spreadsheets, you'd have to do it on a smaller time scale. Now we'll head over just to show you this stuff doesn't just appear here. There is a setup to it. So I'm going to show you kind of the back end and what that looks like. So in here, you can configure to be looking at several different sources. In this case, we have 2 different SCADA historian sources that we used. You bring in the individual sensors, and we can look at real quick statistics on what types of sensors are in this system. Some of these are real flow level sensors, and other ones are derived sensors or virtual sensors that were done by those mass balances and the biz blocks that we'll talk about a little bit later, that are basically allowing you to do any kind of calculations you want. So there's a mixture there. But that data all comes in, and then you want to know if it's accurate. How often is it coming in? What's the health of my system? So in here, we've got a new thing called sensor health that allows you to pick a sensor and find out how long it's been since it last gave you data. It may be that if it just stopped giving you data, it was last 4 hours, like this one maybe have had problem, maybe a few more than 4 hours. It lets you find out if your problem that you're having with that sensor is a super recent problem, or if it's something that, man, over the last week, it's only been 50% active. So you can find out if it's an urgent recent problem, or if it's something that's kind of always happening and something you want to maybe replace a sensor, or at least send a guy out in the field to go investigate a little bit more. So from here, we'll talk a little bit later. If you find the gaps in that data, there are ways to be able to actually edit that data in a responsible way. We'll get into that a little bit later, but that is one of the new features that's really exciting. So I want to talk really briefly on some of these things. We're going to ask you a poll question kind of regarding these, just to gauge some interest. But these are well, we should have some smattering conversation of as we talk through some of the next points, where we go into some of these in detail. But these are 6 of the ways that basically reasons why people have bought Info360 to go and solve some of these specific problems. So we'll go ahead and launch the poll question, and I can talk about some of these as that's going, so you guys can can look at it. But question is, which of the following use cases is most interesting for you and your utility? If you're a consultant, for the utilities that you work with. There are, again, the most fun thing about working with different cities on things like, when we first started doing leakage analysis, we realized, and I'll go into detail about how we could quickly do some actual pipe failure and calculating the water loss from that. Some of these have led to others. We did a lot of early adopters of this, had done things to keep models up to date, which is still a popular reason to kind of get this data available to people. But we found a lot more kind of operational tasks that have been pretty exciting. So I'm seeing the polls coming in. We've got quite a few voted. We'll leave it open for a little bit longer. There are 4 answers that are all kind of in a dead heat here, all kind of around 20-ish%. So this is the kind of thing at the end, if there's specific things that you want to ask, feel free to ask questions in the question bar right now. But at the end, if you want more information and want a detailed discussion with any of these, please let us know. We can talk at length at most of these data points. I think we can close it up now. Yeah, we ended up with almost all of them kind of tied there. So before we get into the methodology on how we can move towards some of these solutions, I want to talk just about how noisy this space can be. I think a lot of you guys have probably recognized this, but the word smart water, everyone's talking about big data analytics. People are starting to make some more use of their AMI and AMR data. Ton of people in this space, and we really want to emphasize, yes, there's a lot of noise, but we need to take a practical approach to some of this stuff. We need to not buy the thing that, I guess, that promises to do the world all in one if we don't know one specific example of why we want to use it. So that's what I talk to my customers all the time about is, okay, you saw a webinar. Like, I hope this webinar inspires you. I hope I hope that you're excited about it, but I don't want anyone to go and buy this without knowing what they're going to use it for. So we're gonna dive into this and say, kind of give you a plan on how you should approach this decision and how to move forward. One reason alone is to move away from things like this. And so what I want you guys to think about as you're watching this presentation, or this is super engineering. This is something that I worked on for, I think I started working on it at the beginning of that decade that I was doing hydraulic modeling and master planning, and continue to work on the same spreadsheet to fine tune it and get it to be what I want it to be for quite a while. But it's really painful. If someone comes in here and changes something without me knowing, or puts in a number slightly wrong, it's really easy to mess this up and not know how to fix it. I have a feeling that this same spreadsheet is not still being used at my consulting firm that I was at, because it was pretty complicated on the back end. So I just highlight this because I think this is, I want people to think of other things that they have that might look like this, or in an operations world, is there a simple tool that you have in Excel that you've made, but you have to spit out the data to first be able to analyze it, so you have to export it from somewhere first, hard to get to that data, things like that. So think about what in your current workflow is painful, as far as things that require you getting data and manipulating data, and then hopefully we can talk through some of the ways that we can improve that for you. This is what that same graph that I just did, my same spreadsheet that I had done that would have gotten me 1 day's worth of SCADA data analyzed into demands. Is what I already kind of showed you in the demo, but this is what's available live, as the data comes in. So this is the real benefits here. We can go into, I've got other webinars that I've done specifically on the mass balance, but it's the ability to trend the historical data, to look at the seasonality in the data, and to know that I can scale any of this to a specific pressure zone or a specific DMA, look at the system as a whole and see how that compares, find out who's using the most water, things like that, that would take full different spreadsheets in this case. So that's just showing you kind of old school to new school, what's kind of possible. And now I want to go into kind of the main structure of what I want to accomplish today, and helping progress people through that thought process and how we take steps to action. All of this, by the way, if you reach out to me, my email's at the end of the presentation. It's brett.sangley@innovise.com. But we have a paper that some of my coworkers created for Ozwater in Australia that goes over all of this in vivid detail. So we can definitely supply anyone with that paper that would like to see this in more detail. But the steps to going from kind of lame data that's just sitting there to action are to first source and configure the real-time data. Capturing that data, getting it into one place so you can start to work with it. The next step is identifying the key performance indicators. If you don't know what you're looking to solve, you can't figure out what KPIs you need to solve those problems. So looking at what's available to you and starting to identify those things that you care about monitoring. Next is making analysis on those key performance indicators. This specific indicator went up over the last 6 months, or it took a spike in the winter. What does that mean? Starting to be able to analyze that for understanding your system a little bit better. And then once you understand your system better and have that insight, you can take it forward to take action on it, to enhance your replacement program for leaks and because of leaks, to create a new plan, just while I'm on the leak mindset, to be able to go in and create a monitoring with some of the different technologies that are out there now to really locate those. So that's the process we're going to go through. I won't spend forever on them, I promise, but I do want to hit a couple high points. The sourcing and configuring your data. This is where, again, the sensor health comes into play. And I do see a question that came in. Someone's asking specifically, how do you know if the results are coming in? How do you know when the last valid data came in? The software itself is checking constantly for it, and so this just shows you uptime. So even if the number is 0, but that's a real number that comes in, it will be able to tell the difference and tell you whether you're reading real data or if there were nulls going to SCADA or to whatever database you might be looking at. But it's important to not only be able to check to see if the data being there is a chronic problem or a temporary problem, but being able to, as soon as you've found that problem in your sensor health, that I've got something that has been down the whole hour, but maybe that's something that's really critical to another piece of analysis that I'm doing. So what I can show here is this is that data authoring that's brand new in the software, where if you are an advanced user, you've been labeled as such when in your login, you can come in and actually edit the data points that were missing or that you want to change. And you can do that with block editing. In here, you've got the revision history, so it's keeping track of what the original data was at all times, but it's also allowing you to change it and do that in bulk. So you can bring things up or down by a certain amount. You can multiply them, divide them, do any of those things that you want. Always being able to revert back to the real data. But the reason why that's important, to not just accept the fact that, oh, I had a bad data point, is we're now doing an analytics on a lot of that stuff, right? So if you have your usage patterns and there's a big gap in your biggest supply, you're going to have super incorrect demands in that segment, and your estimate is probably a better use than a void of data. So again, you can always see what's been edited so that you can make sure that you understand that that's estimated data, but it allows you to still have useful long-term trending of that information that's really convenient. The next step in that process was identifying the KPIs, right? We need to figure out what we have as far as measurements in the last one, but now how do I mix together those things, right? How do I mix together the upstream and downstream pressure to find out more information on a pump KPI, for instance? So here are those things that people are using already that we talked about, the ways people are using the software to solve problems. And I threw in some of the KPIs that are needed to do that, right? So pump efficiency was one of the earliest projects that we did at Yorba Linda. Actually, we realized that we had all the information at our fingertips to do a pump curve. This is years ago. We had no intent to do it originally, but the product was able to, with our biz blocks, we were able to create a live pump curve and actually see how things change year over year as far as your pump efficiency. Each of these KPIs is possible because you have access to live data, and some of it also requires information from other systems like your GIS, or maybe a separate water quality database that you're storing all that data in, a LIMS system or the such. But making sure you understand what data is available and what's needed for any given KPI is very important. The third step is for actually doing the analysis. We'll spend a tiny bit more time in this one. Once you've created some KPIs, there's some fun things that you can do with the software to really dig in and find out what's happening, right? It's the fact that there's something that shows up on an alert doesn't necessarily tell me what exactly is wrong. This little GIF is showing something that was really exciting, where we wanted to see if we could figure out, based on some really simple statistics, basically doing something similar to 2 standard deviations away from the mean of a flow throughout a DMA. So we're basically saying, if something is, out of the 95th percentile, and you can play with that number. We played with 97th, 96th. It's really easy to play with those things in here. But if something is basically outside of normal far enough that we can trigger on it, or that we'd want to trigger on it without having a lot of false positives, what we've done is basically said, okay, if I get one weird data point, that's not that interesting on usage. It could have been a pump turning on that caused things to read a little differently. But if I get 2 in a row that are a certain distance above what my normal usage is, let's start to pay attention to it. So we can set an alarm that says, hey, when I have something that's 2 readings in a row, in this case it was basically, that's a half an hour has gone by where we've gotten high flows, let's flag it and let's see if we can start calculating how much above the average it is. So this quick example was showing, when we did it really sensitive, that we could see when people were flushing. So this is different flushing in that same DMA that was happening over time, and this is the amount of water that was flowing as they did some of that flushing. The bottom is the cumulative for those. The other one that we go to shows a break, and I've got better visuals to talk about that break, but it's all on this same set of data that, again, you can set any kind of search parameters on to go find out when you spilled more than X amount of water. In here, I've got my story to tell. So we connected Info360 to a client, and they said, oh, we just got done not too long ago analyzing, having our engineers figure out how much that pipe break, how much water spilled out because of that pipe break. So using the methodology I just mentioned before, we're able to find that break in that system. We were able to figure out the exact time without them telling us where it was. We said, that's great that you guys know what it is. We want to show you that we can find it without you telling us. So we could go back and we can find that time where we get this quite a bit of flow going through the system, and the total cumulative flow, when we applied those statistics, we ended up with calculating, this is in megaliters, so 2.7 megaliters. This was down in Australia. But now let me tell you the real story about what happened. So the data told us that there's an event. Let me tell you about how this happened, and I got this reaffirmed to the client visit I was just at yesterday, actually. They said their best leakage detection, or their only leakage detection in this case, are their customers. So that's what happened here. So in the actual event that happened, the burst happened at 11 p.m. on a Thursday night. It did not get reported until 9 a.m. on Friday, when a mom was taking their kid to school and their street was submerged, completely flooded. They couldn't get in or out. They called up and said, why is my street underwater? So it's quite a bit of water on a single street, about 0.7 million gallons. The software was able to catch it because we told it how frequently we wanted it to check, right? And this is pretty, having 15-minute data come in is pretty conservative here. But with 15-minute data come in, we had it, we could trigger it out on the first half hour. We were able to say, we could have shown you that that was definitely an anomaly. And even though it still takes time, it took them still from 9 a.m. to 2 p.m. to find out where that, how to shut down that area to fix that leak. The investigation could have happened well before any of the major leaking, probably even before it got into the street at all, while it was still almost all underground. They probably could have at least shut down that DMA temporarily to figure out those problems. So it went 10 hours completely unnoticed. And so we believe that they, with this, had this been installed before that break had happened, probably could have prevented about 2 million of those megaliters. Last thing is, what are you going to do with those insights, right? We can gather that information. We can't just look at that last graph and say, oh, cool, we found a break. We want to do something about it. We want to change the way that we react, change the way that we proactively do things about those. Given other presentations, again, we're happy to come and talk to you individually about breaks in particular, but where we use that data to help us create a better plan and to help change our asset management plan. So there's benefits to being able to show how often you're flushing, or these different KPIs, how robust, how much is this pipe deteriorated? Should we increase its maintenance schedule so that we're checking on it more often because it looks like it might have potential failure soon? Things like that you can gain from that insight. One of the ways that you can be alerted to those things a little bit faster is some of these changes that we've made in our alerts. So you've got a map up top. You've got the ability for any of those alerts, whether that's on a live sensor that is coming in directly from SCADA, or whether that's a calculated data point that you have, like we did the pipe burst, right? So we can do alarms and alerts on any of those things. When an alert comes in, you have the ability to come in and say, oh, okay, this is a low level alert. It's got a scale, 1 to 5. This is a 1. We don't need to do anything. We can just close. I was just interested in how often it happened. Or we can go in and say, oh, this needs to be taken care of right away, and you can kind of take notes on whether these have been taken care of or not. We've had a lot of fun. Emails can be triggered, texts can be triggered to alert someone that that we need to send out the crew. So you get an email or a text at us in the middle of the night. You can send people through with your work order system that you use, or any other asset management stuff that you might be using, to send people out to actually go and take action on those. Here's one that's a little less immediate, right? So this is that pump curve, the live pump curve that we're looking at. And so this shows us that we have these clusters of usage in specific pumps. We found in Yorba Linda that we had 2 identical pumps that were installed that were giving us very different output, getting about, I think it ends up being about 10% less flow at any given head, because one of the pumps had been used more than another. This is an example where here at the bottom, as we scroll down, you'll see some pie charts to show the actual hourly usage of each pump. So this is one where the pumps are being traded off very well, and you can visualize that and know that you're going to be wearing out your pumps very evenly. So the 2 different colors are 2 different pumps at the same pump station, and you can analyze that just at a glance to say, okay, we're still doing well there. And the graphs at the bottom were a 90-day look and a 30-day look. So that kind of stuff is really important. So being able, again, there might be someone in engineering that has no use for knowing that information, and that's maybe a really heavy operations thing to make sure that they are wearing out those pumps evenly. But maybe that usage pattern that can be used in the hydraulic model, or can be used to help plan for future system analysis when we have a better mass balance idea over usage pattern over winter versus summer. Those are really useful things that you wouldn't have insight in if you weren't looking at this. And obviously the whole point here is to take action. So what would you do if these were misbalanced? If one was being used way more than the other, you can go and talk to your team and change the way that you operate them and take action there. Kind of this last, wrapping it up, I just want you guys to know that it's happening now. People are doing this. This is something that is actively installed, that people are taking some of these actions and improving the way that they're running their water and sewer districts. I believe we've hit these kind of to death. Yeah, just I want these to stick out. I want you to let us know which of these we can help you with. But the last slide I have here before we go to 2 more quick polls is an important discussion to have. When you're building this plan, when you're going through those 4 steps that help you go from dormant data to taking action through this analytics, you need to know who the stakeholders are inside your company. Those silos are very real that we talked about at the beginning. I just met with another client 2 days ago that they've got 5 different divisions within their water district. Occasionally they'll be able to get together on certain things, but none of them actually have access to the live data that they need to do their work well. It's so common, and we can help break down some of those barriers. This tool, when we can get those different stakeholders in the room and realize that, oh, if you don't, as an engineer, if you need data, you're pulling away an operations guy from his day job, and that causes them more grief. So having those conversations, we love to facilitate those to show how people have changed the way that they operate and can communicate much better with better maps and more democratized data. It helps, obviously, helps you innovate and be more creative when the data's at your fingertips and it's easy for you to manipulate. You'll be more willing to try something versus hoping that if that 1 day's worth of data has something interesting that you dumped out of SCADA. The other things just to note is there are external people that you might want to talk with. In some of our most advanced water systems in the world down in Australia, they are actively pursuing data analytics members of their own team, right? So to do some of these things. We have tools that they've been very excited about and have loved the flexibility of and created some really interesting things. But our whole focus is we want to make sure that we have provided you some tools that are easy enough that you don't necessarily have to have a data scientist right now. You can easily, just doing simple math that you're already doing in a spreadsheet, create a lot of value and insights so that you can act upon them. We also just want to recognize that market forces are driving down a ton of costs for that being to individual sensors that are becoming much cheaper that you can get out there. Whether or not you want to connect those to SCADA or not doesn't matter to us. We want to be there to help you connect those pressure gauges that you're just sticking on hydrants. To be able to get that all integrated with the stuff that you do have coming in from SCADA is really important, and not keep all the different manufacturers and people that are helping you gather that data, getting it all in one spot so it can be used together. With that, we'll go ahead into our last two poll questions. I'm interested just to find out which groups you find, whether or not this is your group, where you think this stuff might be the most applicable, who it might help to have access to this kind of data. It's been really fun. Again, when this product was super young several years ago, we were pretty much only talking to engineers, but the operations teams have really given us a lot more fun stuff to play with, and management just drooling over some of the KPIs that we can get there that they have to do. I had one client that particularly said that they have to do a water conservation report every month, and it was because it was all SCADA related data. It was taking them 24 hours of management's time just to create the report and get the data all squared away, and they had to do that once a month. So real fun stuff there. The results on there look pretty good, pretty even, quite a definite 2/3 are saying kind of all the above. So that's exciting. We do believe that that is the whole reason that this has been such a successful tool, is breaking down some of those silos that we talked about earlier. The last one is just how can we help you? I will answer questions after this, but want to know if you'd like a demo, if you want just some more information. If you have other feedback that's not related to this, we always love to hear any information that you have, any comments, questions. On the next slide, once we get there, my email will be there, so you can write it down there. And yeah, feel free to reach out at any time. We'll leave this one open just a little bit longer. And I'll start looking through some of the questions. I think that wraps up that one. Let's go on here. Again, here's my email address. I'm hearing a little bit of choppiness. I'm not sure if that's Lauren trying to chime in. I can actually read the questions here, Lauren. Most of them, I'm not sure. We've got quite a few that came in throughout. Hopefully some of these I might have answered during. I'll see if I can kind of merge some together that look somewhat similar. We had a question on what's the difference between this and InfoNet. InfoNet is an old name of a product that has recently got some really cool new enhancements in it. It's called Info Asset Manager. That is a product that really helps you on the asset side to look at, do some work order information. You can have the mobile element there that can help push information. So that is live data. It's not telemetry data that is levels and pressures and sensors, but that is some really interesting data that is really useful inside of in understanding. But that is an asset management project. This is way more aimed at the live data coming in from different sources as far as again, pressure sensors, water quality sensors, whether things are on and off or open or closed. So this is gathering that kind of information so that you can actually effectively maybe go trigger a work order so that someone can go and find out that there might be a leak somewhere and things like that, which is what you would do with Info Asset Manager. So we've got some questions about some competing products that is this like X, Y, or Z? There's several there. I guess what I want to say is, yes, there are other people that do some data visualization. Where we pride ourselves in is our customer service, but also the fact that we've been in the water industry for a really long time, for decades. We use your feedback to help advance our products, and we believe that what we have here is significantly different than a pure data visualization tool that doesn't know about mass balance and doesn't know about pump curves and things like that. So we've built the tool really around trying to make some specific things that will really help water and sewer professionals do their job better and kind of empower you to make those things. Questions about some people using some of our modeling tools. Can Info360 help create those diurnal patterns? Absolutely. So that can be used in drinking water models to help drive the demand in the model. It can be used in sewer models, obviously, to get your dry weather flows. You'd have to create different factors to take out what's the outdoor use in some of those cases, but absolutely, this would be a tool that actually, I've got a whole webinar. If you want to look it up on YouTube, there's a whole webinar on how to update your model more efficiently by using Info360's mass balance to automatically bring in those patterns for you into your model. Questions on, is this supposed to replace SCADA in general? Definitely not. We are grabbing information from SCADA. We are only on the historian. We're grabbing data from the historian. So to answer a question that I'm sure is down this list that I haven't gotten to yet, the security question, we talked a lot about SCADA. We are not trying to supplant anyone's control room as the new de facto SCADA by any means. We are just trying to make that data available to more people. So we are not behind the same firewall. We're not on the same side that has the controlling abilities. We are read-only, and we are kind of usually on the business side of that firewall, so that can be accessed by a lot of people. Do we have any examples where it can help with capital planning, prioritization, along with info asset? So we do have some specific cases. I've given a webinar on that break analysis that we did to show off how you can integrate some info asset things with the insights that you gain from Info360. Again, it can tie directly into some modeling software, so that you literally, in InfoWater, for example, the most popular water product in the States, you click a date on your SCADA run and it automatically updates all your boundary conditions for your model, the tank levels, what pumps were on or off at midnight that night when the model was starting to run, all those things directly. There is a question here on with SCADA Watch, so I will say those of you that have known that name, it was because of the general perception that people were not wanting to talk to us because it said SCADA in the name and they thought it was too risky. We decided to emphasize the fact that we're trying to get this information out to everyone in all directions, which is where the 360 came from. But that we are not, it's not just SCADA data in the first place, but we are analyzing the historical data, we are not in any way able to touch anything alive. So SCADAWatch, if you had heard that name, this is the same product with a lot of cool new enhancements that I showed off today. Getting to some duplicates here. There really are too many to be able to answer. I'm still, are there any pre-processing needs to bring in historical data? You have control over how much, how far back you want to go. Different historians collect the data in different ways. Some just record it when something at a specific level has changed. Others will record it on exact time step. You do need to know that information, but we've done enough of these installs that we kind of know how to, the system is set up so that you just kind of tell us which, you tell the software if yours is kind of delta change or on a regular interval, and then you get to set the control on how much data you want to bring in. So this is all on-prem right now, and so we are bringing in this data, we are sampling the data at the different intervals. So very commonly, we've got people on 15-minute interval data is how often we're bringing it in. When we say sampling, that means that on that 15 minutes, every 15 minutes that data comes in, we know what the highest was in that 15 minutes, what the lowest value was, what it started at those 15 minutes, what it closed at those 15 minutes. So there's a lot of flexibility, and that's just part of implementation. We go over how detailed data you want, and if there's anything weird, like you've got your statuses in SCADA say on and off, and we need to map those to a 1 and a 0, it's all set up to be able to do that really easily. So you don't need to do a lot of pre-processing. There are ways to filter out bad data based on different flags that you might have in your SCADA, but you can also just bring it in and do some of those things after the fact. Another security question. We will try to get to these questions in emails to you, or call you up to answer some of these if we don't get to them right now. Well, one question here is, how much data do you actually need? I think that'll be the one I'll end on here. To do a pump curve, a live pump curve, if that is a concern for you, all you need is an upstream and downstream pressure and flow, which is very common. In some cases, you don't even need the upstream pressure. If it's near a tank, we can use the tank level as a surrogate. It really does depend on what you're trying to accomplish, and so that's why I use that question to end on, because I want to emphasize again, we don't want you to buy this tool just because it's a shiny new object. We want to solve your problems. What is it that you want to solve? If you want to solve, if you want to calculate real-time infrastructure leakage index, there's a lot of factors that go into that. Most of which you already do have, because you're already reporting your non-revenue water in a lot of states. But we can go over that with you. We can show you what kind of things you need to be able to calculate some of those things. We aren't magical. If we can't tell you what the flow through something is if we don't have any inputs, but where we can make the math work, where we can figure out, even based on assumptions in some cases where we have to, if there's missing data, we would love to work with you. We've got dedicated sales engineers in every region of the United States to be able to answer those types of questions and dig into what problems we're trying to solve. So with that, I would definitely encourage you, if you feel like you don't have enough data, I'd love to prove you wrong and show you what we could do with some of the data that you have, just through some quick discussions on what we've seen so far. So on that note, please reach out. If you've asked us to provide you with more information, you should hear from us soon. If you've asked questions, you should also hear from us soon. But don't hesitate to send me an email anytime. Thank you so much for your time.
Thank you, everyone, for attending, and thank you very much, Brett, for presenting today. Again, if we didn't get a chance to answer your question, we promise we will get back to you with an answer. Thanks. Have a great day.